Today we will see examples based on signals and system properties. So the first question given here. So they are asking us to find out whether the signal given is a periodic or aperiodic signal. Okay. So we know that for the signal to be a periodic signal, it should satisfy the condition x of t. Okay. So the given signal here is j into e power j 10t. Okay. So by looking at this, j is the amplitude of the signal, whereas e power j 10t is the complex exponential signal with an amplitude of j. I don't bother with the amplitude. I need to find out whether it is a periodic or aperiodic. So I'll take this term. Okay, this term is e power j 10t, which is cos 10t plus j sin 10t. Okay, so this is the complex exponential signal, which is always a periodic signal. Okay, so I'll take this thing. I know the time period is 2 pi by omega. Okay, here it is expressed as cos omega t. So here omega is 10. So time period is 2 pi by 10, which is pi by. Okay, so this signal is periodic with time period of pi by 5. Okay, similarly we will see another example. Another example is x2 of t power minus 1 plus j into t. Now here we have two terms, e power minus t into e power jt. Okay, this can be e power jt minus t, which is e power j minus 1 into t. So my omega will be here j minus 1, which is a complex number. My frequency cannot be the complex. Okay, so time period is not determined, cannot be determined. Okay, time period cannot be determined. So this signal, as I cannot determine the time period, this is a periodic signal. This is a complex exponential signal, but I cannot determine the time period of the signal, as I have a non-phase component and a phase component, a complex component and a normal component. Okay, because if you see, this is e power minus t is a decaying signal, whereas e power jt, if I have a constant value 1, and e power jt is a complex signal. So it is a damping signal. I cannot determine the exact time period of the signal. That is the reason why it is an aperiodic signal. Okay. So next, I will consider one discrete time signal. Okay, so x3 of n is e power j 7 pi m. Okay, here it is a discrete time signal. So the condition for the discrete time signal is x of small n plus n should be equal to x of n, where n is given by 2 pi by omega into m, whereas n should be an integer. Okay, now if I see this signal, so here this is the condition for the time period. Now if I consider the signal e power j 7 pi n, e power j omega n, okay, then omega naught is 7 pi. Okay, then n is given by 2 pi by 7 pi into some m. Okay, now n is 2 by 7 into m. Okay, now for the n to become an integer value, okay, then what should be the m value that should be multiplied is n should be equal to 7. 2 by 7 into 7 gives me n equal to 2. This is my fundamental time period of e power j 7 by n. Okay, you try to multiply with any number, the least positive integer should be the m. Okay, least positive number that can make n as an integer is positive integer. N as a positive integer should be multiplied with n. Then only the least we get the time period. Okay, this is for the discrete time signal. Now these are the examples of few periodic and regarding periodic and aperiodic types. Now we will deal with other properties of the systems. Okay, now suppose given that y of n is x of n plus x of n minus 2. Y of n is x of n into x of n minus 2. They are asking, first thing is the system memoryless? Memoryless, and determine the output if x of n is a del of n and is the system invertible. Okay, so these are the three questions regarding this problem. They are given the system, they are asking if it is memoryless or not. If it is if this is the input, what is the output? It is invertible or not. Now we will see the first thing. Is it memoryless or not? So for the system to be memoryless, it should have only the present value of the input, present time instant of the input. But here it is having a delay time of n minus 2 here. So whenever I consider y of 0, I will get x of 0 into x of minus 2 also, which is having a memory of time sample minus 2. So this system is not a memoryless, not a memoryless, not a system. Now second thing, whenever x of n is a del of n, then what will be the output? Okay, so y of n equal to, in the place of delta of n, x of n you place this a into del of n, a into del of n minus 2, that is a square into del of n into del of n minus 2. Okay, so I know that this del of n is only defined at 0. Okay, so whenever I suppose I consider 0, del of a of 0, y of 0, then this will del of 0 and del of minus 2. Okay, so that means a square into del of 0 is 1, but del of minus 2 is 0, get the output 0. So y of n for this input will be always a 0. Okay, next, is the system invertible or not? Okay, the system, you can say y of n is x of n into x of n minus 2 is not an invertible system. Why? Because it is having a present value function multiplied with the delayed value of the function. Okay, so whenever it is in the multiplication form, we cannot have the inverting of the system, because what is the inverse of multiplication? It should be the division, right? I cannot divide the signal by the state by the cannot divide by the input signal by the input, right? Only I can have the constant. If it is any constant type, then I can get the input, but I can get the same input. But when it is of two functions, I cannot have the system to be an invertible system. So even this is not an invertible system. The answer is A. Okay. So these are remaining more or less an invertible systems. Okay. Next question is y of t is x sin t, x sin of t. Like if you take x of t, they are given x of sin t. So they are asking the system is causal and the system linear. Okay, two questions. This is the equation given. They are asking the system is causal or linear. Now for system to be causal, you should have the time sample output inputs of present and past. There should not be any future value in the input side. Okay, so if I consider this now, y of t equal to x sin t, I'll check for the present, past and previous inputs. Okay, so I'll consider y of 0, then it is x of 0. Okay, so this condition is satisfied, but we cannot say that it is causal by only one condition, so I need to check others. Now I'll go with y of pi. This gives me x of 0. This is also okay because it is the future value. Okay, so whenever I consider this is pi, this is 0, this is minus pi. This future value, it is depending upon the past value. It's okay, right? Okay, getting it now. But when I come to the past value, sin of minus pi is x of 0. This is failing here. Even one condition is failed, then the system is not a causal system. Okay, so the past value, it is depending upon the future value. So the system is not a causal system. Not a causal system. Okay. Now coming back to linearity. So I already mentioned you systems which are of type y equal to x of t are always linear systems. Here instead of t they are given sin t, there will be no change, just the time sample will change. X of sin t1, x of sin t2. When I transform both the sides, I'll get the same thing as the output. Okay. So the system is linear, but it is not a causal system. Now we'll take another example of other type. Okay. So next thing is y of t equal to t square x of t minus 1. Okay. They are asking whether the system is linear, time invariant or not. Linear, time invariant or not. Okay. Now first we will check for the linearity, then we will go for the time invariant. Okay, time invariant or not. Now if x of t1 is my input, okay, then y of t1 will be the output, then this will be t1 square x of t1 minus 1. Similarly, x of t2 is my input, then y of t2 will be output, that will be t2 square x of t2 minus 1. Okay. Then when both xt1 plus xt2 are my inputs, then written the time samples here. So when x1 of t is the input, y1 of t is the output, this is t square x1 of t minus 1. When it is x2 of t, it should be y2 of t, then it is t square x2 of t minus 1. Now when I consider both x1 of t plus x2 of t, then y of t is my output, which is t square into x1 of t minus 1 plus x2 of t minus 1. Okay. Now if I see y of t is equal to y1 of t plus y2 of t. This condition is satisfying, so this system is linear. Now I need to check for the time invariance or not. So I already told you in the last class regarding this kind of problems, if it involves any algebraic sum or algebraic constant like t square, anything, it might be t square, then it is a non-linear system. But anyhow, we check for it. First, y of t is t square into x of t minus 1. Now I will shift it at the output side, then I get x of t minus 1 minus t. Similarly, when I change it at the input side, t minus t whole square into x of t minus 1 minus t. Now if you can see, y of t comma t is not equal to y of t minus t. It is a time variant system. Okay, it's not a time invariant system, it's a time variant system. Okay, similarly I'll consider a discrete time signal. Discrete system, then y of n equal to x square of n minus 2. X square of n minus 2. And please don't confuse yourself with the brackets I am putting here. So generally for the discrete signals, this is the bracket, and for the digital signals, this is the bracket. But every time writing this way is not possible, like whenever I am writing on the board, so I am considering this way. Okay, as far as we are considering, these are all discrete signals, not the digital signals. I hope you know the difference between the discrete and digital signals. Okay, that is time sampled, whereas this is non-time sampled. So here y of n is x square plus x square of n minus 2 is given, asking linear or time invariant or not. Okay, now it's simple. We'll go with the normal procedure. First, to check the linearity. If x1 of n is the input, y1 of n is the output, then it is x1 square of n minus 2. x2 of n is the input, y2 of n is the output, that is x2 square of n minus 2. Whereas when x1 of n plus x2 of n both are the inputs, y of n is the output, it is x1 of n minus 2 plus x2 of n minus 2 whole square. So by looking at it, we can say y of n is not equal to y1 of n plus y2 of n. System is non-linear. Non-linear system. Now I'll check for the time invariance or not. So I'll change at the output side, then n comma n, then it is x square of n minus 2 minus n. I'll change at the input side, then it is x square of n minus 2. Oh yeah, so y of n comma n is equal to y of n minus n. That means it is a time invariant system. Time invariant system. It is not a linear system, but a time invariant system. Okay. Now, to be clear, I will consider even another example for this, which involves two different functions. So y of n is x of n minus 1. So n plus 1 minus x of n minus 1. Okay. So here, first thing, consider the linearity. So whenever x1 of n is the input, y1 of n is the output, then my output is x1 of n minus x1 of n plus 1 minus 1. Okay. Similarly, whenever x2 of n is the input, y2 of n is the output, which is x2 of n plus 1 minus x2 of n minus 1. Now, whenever x1 of n plus x2 of n is the input, y of n is the output, which is transformation of that is x1 of n plus 1 plus x2 of n plus 1 minus x1 of n minus 1 minus x2 of n minus 1. Okay, now if you can see, y of n is the same as y1 of n plus y2 of n. Okay, that means the system is linear. Okay, next I'll check for the time invariance or not. So y of n comma n, I will change at the upper side, then it is n plus 1 minus n, n minus n minus 1 minus n minus n minus 1, n minus n plus 1, n minus n minus 1. Now similarly I'll change the input side, then x of n minus n plus 1 minus x of n minus 1 minus n. So y of n minus n is same as the y of n plus n, is the time invariant system. Time invariant system. Okay friends, so these are the examples related to signals and system properties. And if you have any questions regarding any type of questions we have regarding any signals and system properties, you can give the signal in the comments box. Okay, I'll try to solve it and send it to you. And these are the basic types of signals and system properties we have. In the later lectures we'll see what are the linear time invariant systems and their properties. That's all for this video. Thank you.